Now see the first basic property of the charges. First one is additivity of charge. See, according to this property, total charge of a system is obtained by adding algebraically all the charges present anywhere on the system. Suppose if you have taken any system like this, where the charges are present q1, q2, q3 and qn. So, the total charge of this body can be written q is equal to q1 plus q2 plus qn. Here the charges are, if the positive has the positive sign, you have to use the positive sign. If the charge has negative sign, you have to use as negative sign, right here. And the charge has also got magnitude, but it has no direction. So, the charge is also a scalar quantity like similar to mass, but see here the mass is always taken only positive, but the charges can be positive as well as negative. So, according to this property, total charge of the body just can be obtained by adding algebraically. Now, see the second property of the charge, that is a quantization of charge. See, according to this property, all free charges are integral multiple of basic unit of charge denoted by E. So, see here E is actually the charge carried by an electron or proton, and for the electron we write that is minus E, and for proton we write plus E. Now, see here, according to this property, as I have told you, the net charge is the integral multiple of the basic unit of the charge. So, the charge on any body is given here q is equal to NE, where n is any integer. So, n can be positive or negative. So, we can write also here plus minus NE. So, the net charge on the body is an integral multiple of the basic unit of charge E. Now, see here, any body or any atom, suppose it contains n1 number of electrons and n2 number of protons. So, n1 is the number of electron, n2 is the number of protons. So, we can write here q is equal to total charge here n2e plus n1 into minus e, because for electron we write negative charge here. So, we can write n2 minus n1 into e. So, we know n1 and n2 are integers. So, obviously, n2 minus n1 will be an integer here. So, the net charge of the body is given by this formula here. Now, also here these charges are the quantization of the charges are only applicable in case of the microscopic level. Now, see a third one is the conservation of charge. According to this property, the net charge of the body cannot, that remains constant, it cannot be created or not be destroyed. So, here you cannot create the net charge of the body which is an isolated system. So, you can take examples here like in the phenomenon of pair production. So, suppose here if you have taken in the pair production phenomena, like you have taken here the gamma here, which goes here, which transforms into E plus and plus E minus. This is here positive electron is called positron, this is called negative electron here, that is electron here. So, that this gamma has got the net charge 0 here, and also here this is the net charge 0. So, if you add this and this charge, you will be getting net charge 0. So, here in this case the net charge of the system remains conserved.